Okay, so you've had a chance to work on some of your problems now, and I'm sure you have a couple more questions, and I want to give you another example at least, to show you some of the techniques and how we use some of these equations. This is an interesting problem. So a vehicle accelerates from rest at 6.63 meters per second for 4.58 seconds. What is the final speed of the vehicle? How far does the vehicle travel while it's accelerating? Well, do we recognize any terms in there that we might already have an equation for on those sheets? You look at your sheet, you can kind of see that yes, we do. So let's go ahead and start working this problem, and we're going to draw our picture to start with. Okay, there's my little car. Okay, put some wheels on it. And it's going down the road. Okay, and it has an acceleration of 6.63 meters per second, or meters per second squared, and accelerates over a time period of 4.58 seconds. Okay, well, obviously we have some abbreviations here. We need to start defining those out. First step, of course, is our sign convention. Up and to the right is positive. A is acceleration. T is time. We might have to do some velocity here maybe. And distance, D. That's that how far thing, okay? And so since we know there's a time period, there's obviously an initial or starting, okay? And a final, okay? Well, I think that will just about do us for abbreviations in this particular case. And I'm going to go ahead and box that in red so we can kind of keep our eye on it up there, okay? Like I said before, though, you may not want to box yours in so quickly or even at all, okay? So it's just so I can see it when I'm reading it, or whoever is reading it can see it, that's fine. And you might want to add something, okay? So you don't have to box it in. So what do we know? Okay, there's one thing up here that we haven't talked about, and that's from rest, okay? So what does that tell us? That the initial velocity is equal to 0 meters per second, okay? So look on your formula sheet, okay, and see if we can find anything that's going to give us those two answers, right? That's what we're looking for. How far does the vehicle travel, and what's the final speed or final velocity? Okay. If we just say it's going to the right, then that's going to be a velocity, right? So if you look on your formula sheet, of course, we do have the very formula we're looking for. The final velocity is equal to the initial velocity plus the acceleration times the time. We know that. We know that. We know that. Straightforward. The final velocity is equal to 6.63 meters. Whoop, sorry. Let me erase here. Put the wrong numbers in there, right? So the initial velocity, what is that? That's 0, okay, plus the acceleration, 6.63 meters per second squared, times 4.58 seconds. And if you look, this seconds divides by this seconds, and that takes that squared off and just leaves you with seconds. You're going to have a meters per second as our units. And that calculates out to be 30.654 meters per second. There's one of our answers. We'll go ahead and box that out. Okay. You notice I put parentheses up in here quite a bit. It's just to make it clear. You can add as many parentheses as you want as long as you're following the equations and stuff like that, just to make it clear. So look around, look on your sheet and see if you have another formula that's going to help us find this right there. Do you have one? Okay. Should have one that looks similar to this. The final distance is equal to the initial distance plus the initial velocity times the time plus 1/2 the acceleration times the time squared. I don't think yours actually has this initial distance in there. Okay, that's 0. We're going to start at the origin. Okay, this initial velocity is 0 we saw in the last problem, so now it's pretty straightforward. The final distance or displacement is 1/2 the acceleration times the time squared. Now, you notice I might have swapped the terms distance or displacement. The reason is because we're all going in the same direction. We can say to the right, and then that makes it a vector quantity. We can use little letters. I think I used a little letter up here, so those will all be little letters. Okay, so we're just going to say the final distance, swap into little letters because I put it up there. Okay, it's 1/2 the acceleration, 6.63 meters per second squared, times the time squared, 4.58 seconds squared. Don't forget the square. Okay. And all we're going to do is punch that in a calculator. And look at our units. This seconds gets squared and cancels with that second squared or divides out. And we're left with meters as our only unit. And the final distance is 69.54 meters. And we box our equation, okay, or our solution, or we can put little arrows on it, or if you are some of these guys that like to be really fancy, you can highlight your answer. Either way, pull out a little bit here so you can see the whole thing. There you go.